We had over 18 participating projects in SODACODE 2022. It's time now for us to hear from a few of the project leaders and maintainers. First up, we have with us from the CORTX team, Rose Wambui, the developer advocate at Seagate. Please welcome on your screens, Rose Wambui. Hello, Rose.
Hi.
So I believe we are having some network troubles from your end. So we'll just have the session from you on the screen now. And for all the participants, if you have any questions about the session, we can answer them in the Q&A session. Over to you, Rose. Thank you so much.
Hello, I'm Rose Wambui. I'm a developer advocate at CORTX. So what is CORTX? CORTX is developed by Seagate and it's a mass capacity object store. So what led to CORTX being developed? We look at innovations in storage. So what are the challenges that storage is facing in the current world? So we have a lot of massive increases in the amount of data. There is physical limitation to increase in storage. So as we have terabytes and many terabytes of data, the physical limitations to store that data is becoming a challenge. So as data storage scales up, so we're also facing a lot of hardware failures and also the speed of accessing the data. So the more you have the data, the more you need better algorithms to search and access that data. So what solutions are there, or what solutions do we have to look at these challenges? So we want to improve efficiency of the hardware, also reduce the data overhead in storage. So the use of statistics to calculate the most efficient system for ensuring data availability and recovery. So we also want solutions where softwares are designed to compensate for mechanical failure. So how does CORTX comes in this innovation or in these solutions? So the world runs on data these days, and more of it is being retained and stored than ever. We can compare like 20 years ago, the data that we have in this 21st century is a lot. So yet the hard limits imposed by the law of physics have meant that the science of storage has had to become more creative in order to keep up. In addition to developing more exotic ways of storing bits on drives, the software that manages storage has become an important part of solutions. So currently, we are not only looking at the hardware that stores this data, we're also looking at the softwares that manage how that data is stored. So new storage platform can use available storage more efficiently, be optimized for specific uses, such as running simulation, and be designed to take advantage of new development in the hardware to ensure that the data storage, recovery, and retrieval is an efficient, effective, and fast as possible. So Seagate created CORTX, an object storage system to store more data easily at reduced cost. So this is an open source product. And with CORTX, it's possible for more data to be captured and saved on a given amount of storage media without compromising data durability and retrieval speeds. So CORTX is trying to solve the challenges that we have. You don't have to increase your hardware, but with this software, it's able to store massive amount of data. So what are the core design goals of CORTX? We're saying it's a mass capacity object storage uniquely optimized for mass capacity storage devices. It can store terabytes of data. So as more companies are producing more data, we have seen self-driving cars, and such companies require a lot of data to make their algorithms more efficient. So with our mass capacity software, it's able to optimize that data in a unique way. It's also flexible. So it works with HDD, SSD, and NVM. Currently, we know theoretically or even practically, NVM is the fastest device in terms of reading and writing data. So, and by Cortex supporting all this, we ensure that we go with all range of our customers. So you don't need to change your hardware device type. So if you're using HDD, Cortex can also support that. If you're using NVM, the Cortex system can also support that. It's able to scale as more data is added, the Cortex software is able to scale objects with unlimited object sizes. We also have another design goal called searchability. It's able to quickly retrieve data regardless of the scale using a novel key value system that ensures low search latency across massive data sets. So with the novel key value system, we are able to search data. We say that it stores massive capacity of data. So with this novel key value, users are able to search their data efficiently. It's resilient. So we ensure a high tolerance for hardware failure and faster rebuild and recovery times using network erasure coding while remaining fully RAID compatible. So with our erasure coding, we ensure we have spare disk to ensure that you can rebuild lost data. So what are key components of Cortex? Cortex is made of components, other components. We have the motor, the HA and here, we have the management, and now RGW. So what motor does, motor is the core component of Cortex. It's the primary data store. Most of the data is, all the data is stored in motor. It interacts directly with the storage devices. It manages data storage and the metadata. It also rebuilds data after failures. And what helps motor to rebuild that data after failures is the HA and here, because the HA and here monitors the failures and tells motor what to build. We have the management component. So it reports platform health. So with the management, you can see some graphs of how your software is working on, or how your data is. It detects hardware faults, removal, and replacements. So we have the other component is the RGW. So RGW, so we are saying it translates between motor and S3. S3 is an API developed by Amazon for object storage. So it's widely used. So RGW comes in as the module that allows you to connect with motor through the S3 API. So a user will make requests using the S3 API, then the RGW is able to understand that S3 API and translate it into a way that motor can read and write. What are the use cases of mass capacity? We are all talking about mass capacity, but who are the users of the mass capacity object store like Cortex? So in backup and restore, so currently we need to back up a lot of data in case of loss. So such companies that need a lot of backup and restore, like Zoom companies that need to store and back up users' information, big data and analytics. So people who are dealing with a lot of data, they can use Cortex. Then we have IoT, automotive, and sensors. We talked about self-driving cars. These people require very big storage devices to store the amount of data that they receive each and every day. We also have in genomics, we have AI and machine learning. In this field, you can store, for an AI or a machine learning model to be efficient, you need a lot of data and you need to keep training your model with that data. So we say the efficiency of a machine learning model is the data that you feed it to. So if you need massive data, then you need some way of storing it, some way and an optimal way of storing it. So we also have use cases in file synchronization and share, and also in video surveillance. So companies that deal with video surveillance, videos have high amount of data. So CORTX can come in and sort those companies that require to store that data. Yeah, that's it about CORTX. Thank you so much. So if you have questions, you can send an email at cortexquestions@seagate.com. Then you can access our monthly newsletter using that link. And then you can go to GitHub. You can find our code there. It's open source. You can contribute if you want to contribute, and then you can find more information about CORTX on that GitHub link. Thank you so much.
Hey, thank you so much, Rose, for that introduction to Cortex. If we do have any questions, this would be the time now to take them. If not, if we do receive any questions, we will forward them to you, Rose, and maybe we can answer them offline. Thank you once again, Rose Wambui of Seagate.
Thank you so much.
It's time now for us to hear from Yusuf Yildiz, Solution Architect at LINBIT, and he'll be talking about the LINSTOR project. Over to you, Yusuf.
My name is Yusuf Yildiz, and I am working as a solutions architect in LINBIT. In this presentation, I will introduce you to LINSTOR, a software-defined storage, which is a part of SODACODE project. And we will talk about the benefits of LINSTOR, possible use cases of LINSTOR, the infrastructure of LINSTOR in the upcoming slides. Before we jump into the technical part, let me give you a short overview about our company. Our company based in Austria, Vienna, and we have office in United States. And we are the developers of DRBD. Most likely you know this name, distributed replicated block device, and the LINSTOR. And DRBD is the highly available block replication tool, which is in the Linux kernel since 2009. It's actually a kernel module that you load into your kernel and then start replicating block devices between two Linux machines. And the LINSTOR is a software-defined storage that leverages the DRBD and as well as the other Linux common tools, so you can have a complete software-defined storage in your Linux stack. We have partners all around the world, and for example, in Japan we have SIOS, and we have good partners in China and in many other places in the world. Okay, let's start talking LINSTOR. So the LINSTOR is the open source software designed to manage block storage devices for small or large Linux server clusters. So, but what that means is you can install the LINSTOR into your Linux machines, and then you can have highly available storage targets within your system. On the left-hand side, you most likely see a stacked design for the LINSTOR. That means that LINSTOR is covering each and every one of this ecosystem here. So if your hardware can be managed by LINSTOR, your LVM and the ZFS part can be managed by LINSTOR. On top of that, you might want to add some block storage features such as DRBD, which is a replication tool, so you can have the highly available block devices in your cluster, real-time replicated, by the way. You can have looks for the encryption, you can have video for the duplication, or different flavors of caching mechanism within your system. Then you can port these block devices into your Kubernetes, OpenStack, OpenEBLA, OpenShift environment with iSCSI, NVMe over Fabric, DRPT's diskless mode, which is far more powerful than any of them, and maybe NFS if you want to use it. And on the orchestrator's part, LINSTOR also has many connectors, which I will explain one more slide later. So you can add your LINSTOR devices into your system pretty easily. So let's talk about the LINSTOR's benefits. So LINSTOR is separated the data and the control plane. The data plane is handled by the RPD and the control plane is on LINSTOR. And with the data plane always handled by the RPD, you can easily upgrade, downgrade, and disable if you want to do it at LINSTOR in your cluster. That means the LINSTOR is not sitting in your data plane, and you can upgrade your existing LINSTOR cluster without having any downtime. And the LINSTOR is giving you the top performance because it has the RPD for the replication part, which is the fastest replication technology in the world right now. And it uses the data locality because the RPD always doing grade 1 replication within the machines. That means if you have one block in one machine, that one block device in one machine, you will have the exact same block device in another machine. And LINSTOR gives you no vendor lock-in, obviously, because it can run in any Linux system. So you can mix and match different kind of Linux the hardware vendors if you want to do it. And it can scale up indefinitely, obviously, and you can have thousands of resources, thousands of nodes within your cluster, which is justified with one of our customers actually. And it is open source. It is open source, and if you want to use it, you just need to download and install in your system as much as you like. All right, let's talk about the LINSTOR connectors. So I mentioned that LINSTOR is meant for the container ecosystem, but it's not just meant for the container ecosystem. So you can use it in your virtualization systems such as OpenStack, CloudStack, OpenNebula, XCPNG, Proxmox, and so on. And it is well integrated with these systems, so you don't have any issues like installing, how to do it, and so on. We have the user guides in our website, so please check and try it. If you have any issues, just let us know. We can help you with from our Slack channel. But it's best for persistent volumes in Kubernetes ecosystem, and we lately integrated in Nomad and obviously in Docker. And LINSTOR is not just for the on-premise. You can also use it in the cloud ecosystem like AWS, Google Cloud, Microsoft Azure, and so on. We also integrated in Juju Charms and Terraform, HashiCorp's Terraform. So if you want to do some automation and stuff, you can easily do it with that. Let's talk about some of the sample usage of the LINSTOR. In this example, you see a hyper-converged environment, and left hand side you see one node has one VM. Let's say this is an OpenNebula system, all right, and a local storage node here. That means if a VM has the, let's say, two-way replicated block device in the LINSTOR side, that means one local copy will be here and one other remote copy will be here. If something happens to this hypervisor, and if this VM moves into another node, that means that LINSTOR will create another local copy while it's reading from the remote copy without any downtime. That means your VMs will keep on running even if the hypervisor or the storage completely goes down. Your VMs will keep on running from a remote replica without any issue. And this one is also very well suited in Kubernetes too, because Kubernetes is more like hyper-converged environment in terms of design. And LINSTOR also supports the disaggregated stack, so you can have hypervisors, or let's talk in container world like worker nodes, but you might have some disaggregated stack for your storage devices. That is also a possibility. And when that happens, the VMs will use and consume the storage devices with the RBD's diskless mode from these storage nodes. And if the hypervisor goes down or one of the storage nodes goes down for some reason, it doesn't matter. The VM will move into another hypervisor, or the active storage node will move into another one without any issue. This is also possible with LINSTOR, and this is also providing you highly available storage targets, highly available VMs, highly available system to your clients and you. This is a very short summary of LINSTOR, and thank you for listening to me. If you want to get informed about LINSTOR more deeply, please log into our website, which is linbit.com, or you can jump into our Slack channel so we can help you out with the questions that you have in mind. And thank you for listening. Goodbye.
Thank you so much. And we have Yusuf here available if in case anyone has any questions. If you do post them and if we can't answer them at the moment, we will get them answered to you at a later time. Thank you so much, Yusuf, for being here. It's always a pleasure to have you at our events.
You're welcome. Anytime. I really enjoy joining SODA events all the time.
Thank you so much, Yusuf. And that was a very great presentation on LINSTOR. We will now move on to the next one. Thank you once again, Yusuf. We will forward any questions if we have them. With that, now it's time for us to watch Leon Chang, a storage technology architect from one of our platinum sponsors, OPPO, who's going to speak about CubeFS. Over to you, Leon.
I'm Leon Chang from CubeFS team of OPPO. It's my great honor to introduce CubeFS today. CubeFS was formerly named CubeFS. In the field of storage, there are some technical challenges. For example, it has to deal with files from KB to TB. What's more, it's hard to use read-write patterns sequentially or randomly. CubeFS helps to improve efficiency and reduce cost. It has the following key features. Most importantly is elasticity and scalability formatted, optimized for both large file and small files. Support Erasure code. CubeFS went open source in March 2019, released version 1.0, and at the end of 2019, we joined CCF Sandbox. In the following year, it updated several times and supported diverse interfaces, including S3 and HDFS. This year, we released version 3 in April. In terms of open source community growth, we compared the data before and after joining Sandbox. The increasing number indicated that CubeFS has huge potential in practical applications. Let's talk about its architecture. It includes 4 subsystems. We made some improvement mainly in this subsystem in third version. We added Erasure code. Generally speaking, there are the main traits of the updating of architecture. Let's move to Erasure coding subsystem for the details. The left figure shows the components of the whole Erasure coding subsystem and the flow of data. The right figure shows the distribution of the data in different AZ and EC modes. Of course, CubeFS directly uses online EC. This avoids data migration and saves storage space. Next, I want to introduce the multi-layer storage. According to storage cost and performance, CubeFS provides 4 storage layers listed in decreasing order by cost and performance. The structure sees the data the date gradually change from how to code across the layers. The first layer is close to clients, so it acts as cache with high frequent visits to date. In general practice, to adapt to different trees of services date storage, we could use flexible strategies of volume configuration to optimize cost and performance. Next page is durability. An important factor in durability calculations is the disk failure rate. The distribution of replication group composed of multiple copies is adjustable. Random replication makes replicas scattered, reducing the degree of dispersion, which can improve the durability of the storage system. Domain management unit is added for the cluster management. In the domain area, copy size of different zones are formed into failure domain group. The resource application formatted and date is applied from the failure domain group, and we will build multiple domain areas, and different services can use different areas. Next is the flexible replication strategy. The above figure shows is the deployment of 3 copies. The client and data subsystem are deployed independently. In replica options, we can choose single replica to 3 replica. The lower the number of the replicas, the lower the overall cost. Let's focus on single replica. It reduces TCO and network traffic. Besides, it significantly reduces writing latency. The above talk is about new technical points of CubeFS. So now let's talk about the user adoptions in OPPO. OPPO is a consumer electronics and mobile communications company, which have more than 20,000 engineers. We put CubeFS in 3 parts in practice. AI platform, data lake, and Spark remote shuffle service. Now let's take a look at the AI platform. As the underlying storage of the AI platform, CubeFS solves a series of pain points, such as massive small file storage, millions of directories, and hot data access in machine learning scenarios. So much for introduction because of the short time. Welcome to join us. Detailed contact information can be obtained at GitHub. Thank you.